Hello everyone, hope you're all doing well, having a great time, and of course staying safe. So this is Class 9 science lesson. This is the end of chapter 12. So this will be the last lesson for this year. And in this lesson we will try to talk about what is heat or heat in general. So let's start. So let's start this lesson by asking a very important question. What is heat? Heat is the transfer of energy between objects that are different in temperature. Okay, so whenever a metal or you touch a metal, you can feel that metal being cold. What makes the metal feel cold? Well, the answer is related to how energy is transferred between metal and your skin. So in this section, we will try to talk about how energy is transferred, and you will also learn about the kind of energy transfer. But let's start with the transfer of thermal energy. At some point in your life, you went to a doctor and you had a physical examination, just like a little kid in a picture. So doctors usually use a stethoscope. Now, stethoscope is made of metal, so when it touches your skin, it feels cold. Of course, we will talk about the reason behind that. But first, if I told you heat, what does this word means to you? I'm pretty sure you are thinking about hot things or things that feels hot. But you should know that heat also has to do with things that feels cold, such as the stethoscope that I have talked about. Now, heat is what causes object to feel hot or cold, or to get hot or cold under the right conditions. Just like I said, heat is the energy transfer between objects that are at different temperature. Why some objects feel hot, other objects feel cold? When we have two objects, like your skin and the stethoscope, at different temperature, and they come in contact, energy always transfer from object that is higher in temperature to the object that has lower temperature. When the doctor touches your back or your chest with the stethoscope, the energy is transferred from your skin to the stethoscope because your skin obviously has the higher temperature. So your body temperature is about 37 degrees Celsius. What about the stethoscope? The stethoscope probably has the room's temperature, about 20 degrees Celsius. So remember, why the stethoscope feels cold? Because the energy transferred quickly, so the stethoscope feels cold to you. Heat and thermal energy. If I ask you a question, the question says, what forms of energy is being transferred? The answer is thermal energy. So what is thermal energy? As you can see in front of you, thermal energy is the total kinetic energy of the particles that make up a substance. You also should know that thermal energy is measured in joules. Also, remember that thermal energy depends on two factors. The first one is the temperature, and the second one is how much of a substance there is. So what is the relationship between the particles of a matter, the amount of particles of a matter, and the thermal energy? Well, the more particles there are in a substance at a given temperature, remember, at a given temperature, the greater the thermal energy of the substance is. Look at the image in front of you. You can see two containers of soup. Now, know that the soup are at the same temperature, but one of them contains more soup than the other one. We said previously that the more particles there are in a substance at the given temperature, the greater the thermal energy of the substance is. So if we have more particles, that means we have more thermal energy. So let's say it again one more time. Both soups are at the same temperature, but there's more soup in the pan than the bowl. So the soup in the pan has more thermal energy than the soup in the bowl. Reaching the same temperature, we have two objects, the juice and the ice. The juice is in the bottle on the ice. Now, these two objects have different temperature. They are in contact, and you already know that energy will always be transferred. So energy will pass from the warmer object to the cooler object. If I ask you what is the temperature of a juice, the bottle of a juice, probably it would be the same temperature of the room, 25 degrees Celsius. What about the ice, the ice water? It will be 0 degrees Celsius. So the energy will pass from the warmer object to the cooler object until both have the same temperature. What will happen if the two objects that are in contact reach the same temperature? Well, in this case, there is no net change in the thermal energy of either one. Even if one of them have more thermal energy than the other object, both objects will be at the same temperature. Let's explain the picture in front of you. So we have a bottle of a juice. The energy is transferred from the warmer object, the bottle of the juice, to the particles in the bowl. The particles transfer energy to the particles in the ice, water, causing the ice to melt. This was the first step. The second step, thermal energy continues to be transferred to the water because all the ice has melted. Step 3 says that eventually the juice bottle and the water will have the same temperature. So what did happen to them? First, we have the juice and the bottle. The juice become colder and the water has become warmer. But all of them have the same temperature, which is 9 degrees Celsius. Let's talk about how thermal energy is transferred. So, thermal energy is transferred in 3 ways: convection, conduction, and radiation. Thermal conduction is the transfer of energy as heat through a material, or you can say is the transfer of thermal energy from one substance to another through direct contact. This is very important because for conduction to happen, you need direct contact. The second one is convection. What is convection? Convection is the transfer of thermal energy by circulation or movement of liquid or gas. So it talks about how liquid and gas, the movement of liquid and gas could transfer thermal energy. You can also say conduction is the transfer of thermal energy by the movement of liquid or gas. The final one is radiation. What is radiation? Radiation is the transfer of energy as electromagnetic wave, like visible light and infrared waves. Let's see how each one of them happens. So if you put a metal spoon in a bowl, hot bowl of soup, the handle will get very warm, although the handle is not in the soup. Why the handle of the spoon gets warmed up? The reason behind this is that the entire spoon gets warm because of conduction. Thermal energy is transferred from the soup to the spoon through direct contact. So what really happens is when two objects, the soup and the spoon, touch each other, their particles collide. And when the particles collide, thermal energy is transferred from the higher temperature, in this case it's the soup, to the substance that has a lower temperature. In this case, it is the spoon. Remember that the object with different temperature have different average kinetic energies. So when they collide, the particles of these substance or these objects collide, what happens is the particle with a higher kinetic energy transfer energy to those with lower kinetic energy. This transfer makes some particles slow down and other particles to speed up until all particles have the same average kinetic energy, which means they will have the same temperature. So this was conduction. Moving on to convection. So convection was the transfer of thermal energy by the movement of liquid and gas. So let's go back to the picture. You have a pot of water on fire. The water is boiling. So what happens when the water boils? It moves roughly in a circular pattern because of convection. Let's go to the bottom of the pot. We have fire under the pot, and the water at the bottom of the pot is in direct contact with the pot. So it gets very hot. As it gets hot, it becomes less dense because its higher energy particles spread apart. Now this warm water will rise through the cooler, denser water above it. Let's move up to the top of the pot, the upper part. At the top of the pot, the particles move closer together. Of course, before that, the warm water will begins to cool or will become cooler. So water particles move closer together, and the cold water is denser, so it sinks back to the bottom, and the cycle begins once again. Now keep in your mind the circular motion of liquid or gas due to the density differences that result from temperature differences is called convection current. The circular motion is called convection current. So what is convection current? Is the circular motion of liquid or gas because of differences in density that was resulted from differences in temperature. Now let's move on to the final way to transfer thermal energy, which is radiation. So we said that radiation is a transfer of energy by electromagnetic wave. It could be a visible light or infrared waves. Now, unlike convection and conduction, radiation can involve either energy transfer between particles of matter or energy transfer of empty space, just like the sun. The energy of the sun transferred through empty space and reached us. If you were sitting near that fire, you will probably feel the heat. So the fire will heat you or warm you up by radiating visible light and infrared waves. What about the sun? The sun emits visible light, which you can see with your own eyes, and other waves such as infrared and ultraviolet waves. And you cannot see infrared or ultraviolet waves. But when your body absorbs infrared waves, you can actually feel warmer. Now we will move on to thermal conductor and thermal insulator. We have materials that actually conduct thermal energy very well. These materials are called thermal conductors. Metal stethoscope is a conductor. Energy is transferred rapidly, means very fast, from your warm skin to the cool stethoscope. What about Dr. Wooden Tongue Depressor? That is insulator. It is an insulator. So a thermal insulator is a material that reduce or prevent the transfer of heat. Remember, reduce or prevent the transfer of heat. Keep in your mind that the wooden stick and the stethoscope have the same temperature, but if you put it on your tongue, the tongue depressor does not feel cold. The reason is that the thermal energy is transferred very slowly from your tongue to the wood. We have other kinds of conductor and insulator, for example, curling iron, cookie sheet are conductors, while oven mitt, plastic spatula, ceramic bowl, these items or materials are insulators. Radiation and greenhouse effect. What is a greenhouse effect? We will talk about this, but before that, we should know how our atmosphere works. So, atmosphere acts like a window of a greenhouse. It allows the sun visible light to pass through it. You know that the greenhouse traps some energy, heat energy, keeping inside warm. Now, the atmosphere traps some energy too. This process is called greenhouse effect. What will happen if our atmosphere did not trap energy, sun's energy? Then Earth would be very cold and lifeless. Why? Because most of the sun's energy would be radiated immediately back into space. The atmosphere traps sun's energy because of the greenhouse gases such as water vapor, carbon dioxide, and methane. Now, some scientists nowadays are very concerned that high levels of greenhouse gases in the atmosphere may trap too much energy that makes Earth too warm. The diagram in front of you shows you how the greenhouse effect happens. First, we have visible light, passes through the atmosphere and reaches the Earth, or you can say heats the Earth. Infrared radiation, IR, is given by the Earth, or you can say Earth radiates infrared waves. Some of these waves escapes into the space. This allows the Earth to cool. But some infrared radiation is trapped by gases in air like CO2, keeping the Earth warm enough to sustain life. Greenhouse gases trap some of radiated energy near the Earth's surface. Specific heat and temperature change. What is specific heat? Specific heat is the quantity of heat required to raise a unit mass of homologous material 1 degree Celsius at a given constant pressure. Or you can say it is the amount of energy needed to change the temperature of 1 kilogram of substance by 1 degree Celsius at a constant pressure. So let's take the swimming pool in a very hot day. If you try to swim in the pool, you will feel that water cooler than the air around it. We can say that the reason behind this is the following. The specific heat of water is about 4.184 joules per gram per Celsius, while the specific heat of the air is 1.039. Although both air and water are heated by the same amount of thermal energy that is coming from the sun, as you can see, the specific heat of water is very high. And this means that it absorbs a lot of energy without actually changing its temperature. While if a substance has a low specific heat, this means it needs a very little amount of energy to change its temperature. Now we said that a specific heat of water and air are different. One of them is high, the other one is low. And this explains why the water temperature is lower than the air. We cannot directly measure energy transfer between objects. Instead, we can calculate it by knowing the substance specific heat, mass, and change in temperature, as you can see it in the equation in front of you. Now look at the following question. The question says, calculate the heat transfer to mass of 0.2 kilogram of water to change the temperature of water from 25 degrees Celsius to 80 degrees Celsius. If you know that the specific heat of the water is 4.184 joules per kilogram per Celsius. What is the information that the question gives me? First, the mass of the water, it is 0.2 kilogram, the temperature before any change, and the temperature after change, which is 80 degrees Celsius. And another information is given is the specific heat of water, which is 4.184 joule per kilogram per Celsius. So let us write down the equation. As you can see, the equation says heat equals specific heat multiplied by mass multiplied by change in temperature. Now each one of them has its unit, so you'll have to write down the unit too. So heat equals 4.184 joule per kilogram per Celsius multiplied by 0.2 kilogram, and we have the change in temperature, which is 80 degrees Celsius minus 25 degrees Celsius. The answer will be 46.024 joules. Why joules? Because kilogram and kilogram cancels, and also Celsius and Celsius cancels. That's why our unit is joules. We reached the end of this lesson. Thank you for your time and thank you for your attention. And your homework will be the chapter review on page 234. Good luck!